Very good morning, student. Today we have to discuss how to find the solution of a given differential equation. So we can say method of solving first order first degree differential equation. So dear student, how to we solve first order first degree differential equation? We have to use different type of the method. First one is differential equation with variable separation. So with the help of variable separation, how we solve the given differential equation, that we have to discuss here. Let's see. So if first we are using the method for this, that is the differential equation with variable separation. The method is known as solving of a differential equation with the variable separation. So here we take a first order first degree differential equation. Here syllabus is only we can say equation of type first order first degree, which is in the form of written dy by dx equal to f of x into y. So here dy by dx only single term is given, and this is the first derivative, that's why it is the first order, and highest power is also 1. So this type of equation is known as first order first degree. And on the right side we take all the other terms containing to x or y. There are some variables which is x or y both are. Now this f and xy can be written as a product form. We can factorize this if possible. Then if you make the factors, then factor can be written in terms of x and y. There are some factors which allow contain x and other factor which is y. So we can write in the product form. So f of xy can be written as g of x into h of y. In all factor containing y, all factor containing x. So when you see this, we can separate this one now. Now the factor which contain x, we take with the dx. Dx will transfer to this side, cross multiply. So right side dx into dx. And factor containing y, we have to take on this side. So this is multiple here, it will be in divide form. So we get dy by x of y equal to g of xy. So this is known as variable separation. Why we call variable separation? Because all factors containing x, we take the side with p of x. Other factors with containing y, we take the side with dy content. So on the left side, all factor or variable is only y, and on the right hand side, only the variable is x. Clear? So now these variables are separated. That's why this method is known as variable separation method. Now after separating the variable, one can easily integrate. Now you have to integrate. So whenever you are finding or try to finding the solution of a differential equation, we always integrate the given equation. Because as we have already seen formation of the differential equation, when we form a differential equation, we find the derivative. Now here reciprocal process is there. When you find the solution of a differential equation, we have to integrate. Yeah? So to find a solution, we need y or curve or function. So to find y, we have to remove d by dx. Derivative remove. So as we have already discussed in the chapter of integration, to remove derivative we use integration, because integration and derivative are the reciprocal process. So here student, here you see we have to integrate this. So now IBS integrating on both sides. IBS, I am writing a short form. You may write integrating on both sides. So here integrate, here integrate. Integration of 1 upon s of y dy dy equal to integration of dx. So now double integration we take on both sides. Clear? So you already know how to find the integration of the function. So here we take capital X of y. This is the integration of the given function 1 upon s small y, and this capital G of x is the derivative or integration of the function g f of x. So finally you get curve like this, f of I equal to g of. So this is the curve, means solution of the given equation. So in this way one can move for the solution of the differential equation. So dear student, this is the general solution, general method or general topic we are taking how to solve. Now with the help of an example we can understand how this method is applicable. So you may write example of 9, find the general solution of example 9. Find the general solution. GS means general solution of the differential equation. That is capital D. I am writing short form GS for general solution, D differential equation. Now equation is given dy by dx equal to x plus 1 upon 2 minus y. 2 minus y and say y not equal to 2, because if y equal to 2 the denominator is 0, which is not possible. So dear student, here see, this is a first order, first degree differential. How can you say? Because there are derivative of the dependent with respect to x is first derivative, that is dy upon dx only, and its highest power is also 1. That's why first order, first degree differential equation of this type. Clear? dy by dx equal to f of x. So on the right hand side we have function which contain variable x and y. So using this method we have to write either in the factor form or they are already given. So here their factor form is already given. Factor containing x, here x plus 1. Factor containing y, that is y by 2 minus y. So separating the variables in solution right, here we are given equation dy by dx x plus 1. So variable separating, or you can say on variable separating we get. So dy, now this term containing y we take with dy, and x term containing x dx. So cross multiply using the mathematics rule. So dy by d 2 minus y and x plus 1 equal to dx. So variables are separated. This is known as variable are separated. So now what we get here, you may write like this. Either you can write this first term or this, any name you can write. So we may write here 2 minus y first factor into dy equal to x plus y dx. Now integrating on both sides. Ideas? If we are integrating on both sides, then we have integration of 2 minus y dy, integration of x plus. Clear? So this is the method what we are saying here. Clear? Let me solve it. So now you know that how to find the integration. This is the integration of the function in variable y. This is the integration of the function in variable x. So as we have already discussed in the property of the integration, that variables are dummy. So one day we write this derivative of integration of 2 dy, that is 2y, minus integration of y dy, that is y square by 2, and integration of x dx, that is x square by 2. The derivative of 1 into dx, that is x, and you take one constant either on the left side or right side. So that you have to take here. So we solve this. So this is the solution. Now we may write in simplest form. So how can you write simplest? You can take variable term on the left side. So this is, we can say, or LCM you may take as into. So 4y minus y square minus x square minus this is 2x is equal, this is C1, then this is constant C. Or you may take minus common. So x square plus y square minus plus 2x minus 4y equal to C. Clear? This is C. C1, C2 and constant C. So finally we are getting solution x square plus y square plus 2x minus 4y equal to C. Here you may write where C2 equal to minus C1 and C equal to, this is 2, we are taking LCM 2, so 2 and this is minus C2. You may write or not necessary, this is, you may take C1, C2 and C. So this is the final solution of the differential equation. So one way we find the solution equation of the first order first degree differential equation. So write down the solution. So dear student, question is what say? Find the general solution of the differential equation dy by dx equal to 1 plus y square upon 1 plus. So you can say this is again of the first order first degree differential equation in this form. Dy by dx equal to f of x comma y, where f of x y is equal to 1 plus y square upon 1 plus x square. Now this on the right hand side whatever given, that we have to write in the form of gx and hx. Gx is the factor containing x, that is 1 plus x. Hy is factor containing 1 plus y. So we may write here dy by dx equal to 1 plus y square upon 1 plus x square. Now on variable separating, we check. If we are separating the variable, means you take the term containing y with dy, term containing x or the factor containing x with the dx. So what we get, dy by cross multiply again, or we interchange the denominator and numerator in diagonally. So what we get, dy upon 1 plus y square equal to dx upon 1 plus x square. Now variables are separated. So when we, according to this method, when variables are separated, then one can integrate on both sides. So ideas. So we have here 1 plus y square dx 1 plus. So integrating on both sides. So integration of 1 plus y square dy. Integration of 1 plus x square. So in this also you need the how to integrate the different type of function. If this topic is your solid, then there is no problem in the solving of the differential equation or to find the solution of differential equation. So you know that dear student, derivative of integration of 1 upon 1 plus y square, that is tan inverse y, variable is y. So tan inverse y, and this is same formula, only variable is change, and we know the variable is dummy. So again integration of 1 upon 1 plus x, that is tan inverse. Variable is x. Then we have to take constant c. So this is the solution. Which is the general solution? General solution of the given differential equation. So in this way one can find the solution. So write down this one also. So here say we are what say the problem states that find a particular solution. So now we find the particular solution, and in the type of solution we have already defined what is the meaning of particular solution. When the constant c or parameter a, b, c have its fixed value, then this type of solution is known as particular solution. So to find the value of c, there should be a condition which is given. Why we are given condition? Then when this condition is given, we can easily find the value of c. And if we get the value of c, it means we are getting the particular solution in place of general. This is the general solution in which we are using c. But by given some values of x and y, we can get the c. So that type of solution is known as a particular solution. So other methods are same whatever we are using in previous two problems. So in solution, first we find general. So here given differential equation is dy by dx equal to minus 4xy square. So this is also in the form of this dy by dx equal to f of x into y. First order, first degree differential equation. Now we have to separate the variable. So on separating variables, if we are separating the variable, with the term contain x with the dx, term containing with y. So this is the product form. So this can be dy y square transferred to this side minus 4 into x into dx. Now constant may be taken on any side. It is not necessary that this constant minus 4 we can take with x dx or with dy. You may take this on this side. There will be no change in the answer or calculation. This constant can be taken on either of the dx or dy. So variables are separated. Variables are separated. Now idea integrating on both sides. So dy upon y square minus cos constant, that's why we take outside the integral. Now you know how to integrate this. Y square can be written as y power minus 2 dy, and derivative integration of x is x square by 2 plus. So integration of y power minus 2 using the formula x power n. So we may write here y power minus 2 plus 1 upon minus 2 plus 1 minus 4 divided by 2, that is minus 2x square plus c. So finally what we get, y power minus 1 upon minus 1 minus 2x square plus c, or minus 1 upon y equal to minus 2x square plus c. This is equation number 1 or solution number 1 or problem number 1, or it is a general solution. If in question it is say find the general solution, then this is the end of the solution, right? Or we write general solution is minus 1 upon y, or you may take y common, but we need the particular solution. So we put what given that y1, then x equal to 0. So we put x equal to 0, y equal to 1 in equation 1. In this equation we put these two values. Then what we get? Minus 1 upon y. Y is 1 equal to minus 2 into x, that is 0 plus c. So minus 1, 0 plus c. So we get the value of c. So now this value we substitute c equal to minus 1 in equation 1. So in equation 1 again finally to find a particular solution, one can be put c equal to whatever value that we have to substitute here. So c here minus 1 upon y minus 2x square, c is minus 4. Now you can take the minus common. So 1 upon y equal to 2x. So this is the solution, or more standard form. You can take reverse reciprocal of this 1 upon 2x is the required particular solution of the given equation. So dear student, one may be find in this way, Chandra, solution of the given differential equation. So what says problem? Find the equation of the curve passing through the point 1 1, whose differential equation is x into dy 2x square plus 1 into dx and x not equal to 0. Clear? Question what says x dy equal to 2x square plus 1 dx. So first of all, we have to write this in standard form. Before that, you see what says find the equation of the curve. Equation of the curve whose differential equation is given. So in the formation of the differential equation, we learned that the equation of the curve means the solution of the differential equation. What is the solution of this differential equation is known as the equation of the curve whose differential equation is this. It means you have to find its solution, but one condition is given, that this curve is passing through the point 1 1. It means we can find the particular solution. Curve means y equal to whatever we are getting mx plus c or this. This curve is passing through the point. It means you can put x and y, we get c. So we have to find the general solution of this. In other language, if we have simplified this statement, then you have to find the solution or particular solution of this equation. So in solution we write here given differential equation is 2x square x dy equal to 2x square plus 1 into di, which can be written as now variable separate x we get with dx. So dy equal to 2x square plus 1x. So variable are separated. Variable are separated. So dy equal to 2x square plus 1 upon x. Clear? Now IBS integrating on both sides. So what we get? Dy integral of dy 2x square plus 1 upon x dx. So integration of dy is y. Now you can separate direction dx x 1 upon x dx, which may be written as integration of 2x square upon x dy. So 2x dx plus integration of 1 upon x dx, or integration of 2x, that is 2x square by 2, plus integration of 1 upon x, that is log x, log of mod x, and plus c1, or you can write c. So this is the integration. Y equal to, so what we get? Y equal to x square plus log of mod x plus c. This 2 divide with 2. So we get the solution y equal to x square plus log x equal to c. Now what say? Find the equation of the curve. This is the equation of the curve. Now it passes through a given. It passes through the point 1 1. It passes through this point, and this should be satisfied by the given point. Clear? So dear student, here we put the, therefore y equal to 1, x equal to 1, log of 1 plus c. So we know that value of log 1 is 0. So 1 into 1 equal to, they are also cancelled. So c equal to 0. So we get the constant is 0. Therefore required equation will be here for required equation, or you can say required equation of the curve. Equation of the curve is what? Y equal to x square plus log of mod x. See, we are doing 0. So in this way, one can find the solution. So question what? State that find the equation of the curve. As in the previous case, we have also find the equation of curve which passing through the point is 10 minus 2, 3. Given that the slope of, we are given that slope of the tangent to the curve at any point xy, and we know that in solution we know that slope of tangent at any point xy is always written by dy by dx. dy by dx means slope of the tangent at general point, but this is given what? 2x upon y square. This is given. Therefore, what we get, both should be equal. So dy by dx equal to 2x y square. So which is a differential equation of first degree, first order. So this is we get the, according to the given condition, first order, first degree differential equation. Now to find the equation of the curve passing through the point means we have to find the solution of this. So we solve this. So separating the variable, we are using the method separating variable. So dy cross multiply y square 2x into dx. Now ideas, integrating on both sides, y square into dy, integration of 2x into dx. So integration of y square, that is y power 3 by 3, and integration of 2x, that is 2x square by 2 plus c. If we are simplifying this, x square plus c, this is equation number 1. Now say this point is passes through the, this curve is passes through the given point which is minus 2, 3. Clear? So you write which is passing the point minus 2, 3. Now this value of the point you have to put in the given equation 1. So we put x equal to minus 2 and y equal to 3 in equation 1. That is y equal to y power 3 means 3 power 3 by 3 x square minus 2 square plus 3. So y power 3, 3 9, 4 3. So solve this c equal to 5. So we are getting the value of c equal to 5. Therefore required curve or required equation of the curve is y power 3 by 3 equal to x square plus 5, or if one may be write in this way, 3 into cross multiply. So this is the required answer. In this way one can find the solution of the given equation when we are given some special condition. So write down this one. Now we take on another very important problem, that is application of this one in daily life. So see what say problem or statement of the problem is state that in a bank principal increases continuously at the rate of 5% per annum. So what is the rate of principal? That is 5% per annum. R is given. In how many years? It you have to find T, that is time. Rupees 1000 double itself. So principal. So we can say principal is given as 1000 and amount which should be double, means 2000. Yes. So as in earlier classes or in 11th classes you have already see how to we solve this type of problem with the help of formula. Now with the help of the derivative we can also solve this. That's why this is very important topic. So you can say let capital P be the principal at any time t. We suppose here capital P be the principal at any time t. Now according to the given condition, condition what say? This will be change. So principal is changing with respect to time, that is dp upon dt, rate of change of principal, that is dp upon dt, rate of change of principal with respect to time is what? At the rate of 5% of the principal. 5%. 5 upon 100% of what? Principal per year. So this is the given. So now you can say this is a differential equation of order first degree. So now we come on our main motto, that is the differential equation of first order first degree. So we have to solve it by separating variable. So separating variable. So p can be transferred with the dp and dp can be transferred on the side. So what we get, dp upon p equal to dt upon 20. So variable are separated. Clear? Now if variable are separated, then we have to integrate IPS, integrating on both sides. So dp upon p 1 upon 20 into dt. So you know the integration of dp upon p like a dx upon x. dx upon x, variable may be coming, it may be x, y, z, p, q, r, whatever may be there. So integration of dp upon p, that is log p. Log p 1 upon 20 is constant and integration of dt is t plus c. Now we want to find the value of this c, or it is c1. Clear? So you may also remove the log, then this will be power to all this. So we can say log of or p equal to e power 1 by 20t plus c1. As we know that when log move on other side, then it will be converted into exponential. As we have already said that the logarithmic and exponential function are inverse to each other. So we can write it this way, or e power t by 20 into e power c1. We may power it plus this, and so that can be written in this form. Now this is a constant again, e power C1 is a constant which can be written as new constant. So P equal to capital C e power t by 20. So this is the equation number 4. Clear? Now we have to find the value of C. For that, initially at the starting, when time equal to 0, principal is 1000. So we put all these values in equation 4. When initially or at the deposit time, the principal is 1000, time is 0. Put here. So P is 1000. C e power t is 0 by 20, that is 0. So we get what? C equal to 1000. Therefore, 4 equation can be written as P into 1000 e power t by 20. Clear? Now we have to find the t. So after time t, the money should be double. So we put. So you can say that after capital T here, principal should be double itself. So what we put now, P equal to double means 2000 and small t replace T in equation 5. In this equation we put P as a 2000 and T small as a capital T. So what we get? P means 2000 equal to 1000 e power capital T by 20. So transfer this side, 2 equal to e power T by 20. Clear? Now if we are removing the e, then again this will convert into log. So log of 2. So what we get? E by 20 equal to log of for the base e 2. So we get E by 20 equal to log of 2 for the base E. So finally